In this lecture, I am going to discuss the design of bolted joints when the eccentric load is acting perpendicular to the axis. So this is case 2 where the load acts perpendicular to the axis of the bolt. So this is the axis of the bolt and the load is acting in the perpendicular direction. So here the bolt and the load is acting on different plane. So that is why it comes under case 2. Okay, so case 1 and case 2 is out of plane eccentricity. Among that, case 1 is parallel to the axis and case 2 is perpendicular to the axis and case 3 is in plane eccentricity. Okay, so here when the load is acting perpendicular to the axis, we will have a eccentricity of E. So for a primary load, we have to neglect the eccentricity and we can assume that the load is directly acting on the bolt. So without eccentricity, the load will directly act on the bolt. So if the load acts here, then what will happen is it will produce a direct shear. So it will try to break the bolt at this point by applying the direct shear load. Okay, so the primary load is direct shear load and the direct shear load Fs is equal to total load divided by number of bolts. Then the secondary load is with considering the eccentricity. Okay, so with considering eccentricity, the load will act here. Okay, so when the load acts here, it will try to rotate the column like this. So this column will be in this position when the load is applied. So here this point is in contact, so this is the pivot point. Okay, so pivot point, and because of the load, it is trying to pull the bolt. Okay, so a pull force is applied on the bolt and the pull force is same as the tensile force. Okay, so when it bends, it will try to remove the bolt out of the hole. Okay, so a tensile load is applied. So the secondary load is tensile load, so you can use the same equation just like the previous case, that is Ft is equal to W L L max divided by L1 square, L2 square, L3 square and L4 square. So if you have another two bolts, then you can add L5 square and L6 square. Okay, so based on the number of bolt. So here W is the load, L is the distance between the perpendicular distance between the pivot point and the load acting, and L1 is the perpendicular distance between the pivot point and the axis of bolt 1. Similarly, L2 is the distance between pivot point and axis of bolt 2. L3 is pivot point to axis of bolt 3. Okay, so after calculating the primary and secondary stress, here the primary stress is shear, so you should not add the two stresses to calculate the equivalent stress. So we have to use the principal stress equation to calculate the equivalent stress. I mean equivalent load, not equivalent stress. So equivalent tensile load Ft equivalent is equal to half Ft plus root of Ft square plus 4 Fs square. So in the place of sigma t, here I have used Ft, that's all. Then if you want to calculate the equivalent shear load, then you can use the maximum shear stress equation, that is Fs equivalent is equal to root of 1 by 2 root of Ft square plus 4 Fs square. So for example, if in the problem sigma t value is given, then you can calculate the Ft equivalent and you can substitute in the stress equation, that is Ft is equal to pi by 4 dc square into sigma t, and you can calculate the value of dc. So in case if Fs equivalent is given, then you can use the equation, you can replace the Ft by Fs, and in the place of sigma t you can use tau and you can find out the value of the core diameter dc. So the first problem, for supporting the traveling crane in a workshop, the brackets are fixed on steel columns as shown in figure. So you can see the image. The maximum load that comes on the bracket is 12 kilonewton. So the load is 12 kilonewton acting vertically at a distance of 400 mm from the face of the column. So it is acting 400 mm from the face of the column. This is the eccentricity. The vertical face of the bracket is secured to a column by 4 bolts in 2 rows. So 2 in each row. So here in this row we have 2 bolts, and in this row we have another 2 bolts. So let us name it as 1, 2, and in this row 3 and 4 in the another row at a distance of 50 mm from the lower edge. So it is 50 mm from the lower edge. Determine the size of the bolts if the permissible value of the tensile stress for the bolt material is 84 megapascal. So sigma T is given. Tensile stress. Sigma T is 84 megapascal. Also find the cross section of the arm of the bracket, which is rectangular. So also we have to calculate the cross section of this arm. So I'll tell you that later. First we will calculate the bolt diameter. So here the load is acting perpendicular to the axis of the bolt, because this is the axis of the bolt and the load is acting in the perpendicular direction in a different plane, not in a same plane. Okay. So it comes under case 2, that is perpendicular to the axis of the bolt. So first let us calculate the primary load. So the primary load is direct shear. So Fs is equal to W divided by N. The W is 12 into 10 power 3 divided by N is 4. That is equal to 3000 Newton. So this is the primary load. Then the secondary load, you can use the equation Ft is equal to, here we have 4 bolts. So 1 and 2 in the first row, then 3 and 4 in the second row. So it is WL, L max divided by L1 square, L2 square, L3 square and L4 square. So to calculate the value of L and L1, L2, L3, L4, first we have to locate the pivot point. So when the load is acting like this, then it will try to bend the system like this. Okay. So your column will be like this. So this point will be in contact. Okay. So when it rotates, it will rotate the, when the load is applied, it will rotate the column and your column will be in this position. Okay. So this point will be in contact. So this is your pivot point. So we have to calculate all the length from the pivot point. So first we'll calculate L1. So L1 is the distance between pivot point to bolt number 1. So this is L1, and L2 is also same. Then L3 and L4 is the distance between pivot point to bolt 3 and bolt 4. Okay. So L1, so here you can see that this distance is 50 mm. So L1 is same as L2. L1 and L2 is equal to 50 mm. So remember that you have to take the perpendicular distance. So this is the axis. So you have to take the axis in the vertical direction. So you have to take the, horizontal direction. So you have to take the perpendicular distance in the vertical direction, either upwards or downwards. So just like calculating the vertical distance, perpendicular distance for the bending. So you will calculate the bending by multiplying the load into perpendicular distance. Similarly, here you have to calculate the length, that is the perpendicular distance. Then L3 and L4. So this is the axis of the bolt 3 and 4. So L3 and L4 is equal to 375 mm. Then L. So the load is acting in the vertical direction. So we have to take the perpendicular distance in the horizontal direction, either left or right. Okay, so this is the pivot point, and the distance, the left side distance is given as 400 mm. That is the eccentricity. So L is 400. Remember that you should not take this horizontal distance, because since the vertical distance, since the load is acting in the vertical direction, we have to take the perpendicular distance in the opposite direction. Okay, so horizontal we have to take it, and the horizontal perpendicular distance is 400 mm. Okay, so now we can substitute all the values W, L. So among this L1, L2 and L3, L4, L3 and L4 is the maximum value. So I have substituted 375, and I have calculated the value of Ft, that is 6288.2 Newton. So remember that calculation of length is very important as far as the bolt design is concerned. So for calculating the length, we have to locate the pivot point very carefully. Okay. So the last point in contact is called as pivot point. Okay, so you just locate the pivot point carefully and calculate the L1, L2, L3 and L4 is the perpendicular distance. So if the axis of the bolt is in horizontal, then we have to take the vertical distance. In the case of L, the load is acting in the vertical direction, so we have to take the distance in the horizontal direction. So after calculating Ft and Fs, then since the sigma t value is given in the problem, I have calculated the equivalent tensile load. So Ft equivalent is equal to half Ft plus root of Ft square plus 4 Fs square. So Ft is 6288.2 and Fs is 3000. By solving this, I can calculate the Ft equivalent as 7489.9 Newton. So finally, after calculating the load, the bolt carrying tensile load, we know that the stress equation is Ft is equal to pi by 4 dc square into sigma t. So sigma t, it is given as 84 in the problem. Ft I have calculated, it is 7489.9. I can calculate the value of dc, that is core diameter. So the calculated dc value is 10.65 mm, and we know that d is equal to 1.2 times of the dc, so it is 1.2 times 10.65. So I can calculate the nominal diameter d value as 12.78. Okay, so here I have calculated diameter d. So the next point is standardization of diameter. So for d is equal to 12.78, so d is pitch diameter. Don't consider the notations given in the data book. Okay, so dc is minor diameter and d is the pitch diameter. So the pitch diameter is 12.78. You can see that after 10, the next standard diameter is 14.701. So this is the standard bolt diameter, and for this 14.701, the bolt size is M16. So the selected bolt for this application is M16. This is the solution. So now we have calculated the bolt size. The next part of the problem is calculation of the cross section of the arm. Okay, so this is an additional part. In some of the problems, they may ask you to calculate the cross section of the arm. So here, the cross section of the arm is a rectangular one. Okay, and no dimension is given. So without a single dimension, we cannot calculate the cross section. So what I am going to do is, I am going to assume a B value of 25, not 250. It is 25. So here it is B and H. So I am going to assume a B value of 25 mm. And when the load is applied like this column, this arm is subjected to bending load. Okay, so you just neglect the bolt. When the load is applied, this column will try to bend. So the bending load is applied. And we know that the bending stress sigma B is equal to M by I into Y. M is the bending moment. So the bending moment is load into perpendicular distance. The load is 12 into 10 power 3 and the perpendicular distance is 400. So the M value is 4.8 into 10 power 6 Newton mm. Further, the I is the moment of inertia, and moment of inertia for rectangular cross section is BH cube by 12. I have substituted the value of B, that is 25 mm. Then Y is equal to H by 2. So I have calculated all the values separately. Now I can substitute it here. Yeah, in the sigma B. So actually in the problem, the sigma value is given as 84. So I can use it. Then M value I have calculated, I and Y I have calculated. So by solving this equation, I can get a H value of 117 mm. Okay, so this is an additional part. In the 20 mark problem, for calculating the bolt size, it will carry 16 marks, and for calculating the cross section of the arm, it carries 4 marks. Okay, so it's an additional part, and it's very easy because we have solved similar kind of problems in the first CO. So here it is subjected to bending load. So sigma B is equal to M by I into Y. And the cross section is rectangular. For rectangle, it is B into H. Without any single dimension, we cannot calculate the cross section. So I have assumed a B value of 25. So mostly in the problems, any one of the dimension will be given. So you can use the dimension and you can calculate the H value. Okay. So the important point is calculation of the bolt size. Remember that the load is acting perpendicular to the axis of the shaft. So the primary stress is direct shear and the secondary stress is tensile. So here this is the pivot point, and be careful while calculating the length. So L is the perpendicular distance. Okay. So for the load, the 400 mm is the perpendicular distance. Don't confuse it, because the load is acting in the vertical direction. We have to take the horizontal distance. Then after calculating the two loads, you can use FT equivalent equation to calculate the equivalent stress. Then by substituting the FT value in the sigma T equation, you can calculate DC and D. After calculating D, you can standardize the bolt size. So the tutorial problem. A wall bracket as shown in figure is fixed to a wall by means of 4 bolts. So the number of bolts is 4. Find the size of the bolts and the width of the bracket. So first we have to calculate the size of the bolt. The safe stress in tension for the bolt and the bracket may be assumed as 70 megapascal. Sigma T is given as 70. So the problem is almost like the previous problem. 2 rows in a bolt. So 1 and 2 in this row, 3 and 4 in the another row. Okay. So here this is the pivot point, and L1 and L2 is equal to 75. Then similarly L3 and L4 is 500 plus 75. And the L, so the load is acting like this. So this is the L value. For calculate, I am talking about the secondary stress. So primary stress is very simple. I mean primary load is very simple. I am talking about the secondary load. Okay, so since sigma T is given, you can calculate the FT equivalent, and from the FT equivalent you can calculate DC, and from the DC you can calculate D. Then by using the D, by referring the data book, you can standardize the bolt size. So the selected bolt for this application is M30. Okay. Then the second part is width of the bracket. So here the B value is given. So in the previous problem I have assumed the B value, but here the B value is given as 20. Okay, so you can use the B value and you can calculate the H value. Okay, so the problem is same like the classwork problem. You can refer the classwork problem. So the calculated H value is 320 mm. So the bolt size is M30. So it carries 16 mark in a 20 mark problem. And the width of the bracket, it carries 4 marks. Okay, so this is how we have to solve the problems when the load is acting perpendicular to the axis of the bolt.